Today we're going to look at how to write a science lab report with a focus on the results. This is in a series of videos, so if you haven't seen the first two videos, I suggest you watch them first. The first video is on background information, hypothesis, and variables, and the second one is on method, and you can just use the QR codes to get to those videos. But again, today we're going to look at the results. And the results section presents the data that you collected during your experiment. It does not include any opinions or explanations. You're just going to give the facts. It will include two types of tables. You're going to have your qualitative observations and your quantitative data. And the proper presentation of the results helps readers clearly understand what happened in your experiment. So in this video, you're going to learn how to record your qualitative and quantitative data. You're also going to learn how to create organized tables and graphs. And lastly, you're going to learn how to calculate the means, but you're not going to include an interpretation. So let's get started. For the results, for your qualitative results, these are observations. So these are words. And you're going to focus on your senses. So what do you see? What do you hear? What do you smell? Or what do you feel? Notice I did not include taste because remember, in science, we never taste anything. Then you're going to make a table to record this data. For your quantitative results, instead of words, this is numeric or numbers. You're going to have two organized tables. One is the raw data, and the second one is the process data. Then you're going to graph the data. Now, if you're not sure what kind of graph you need to make with the data that you have, you can use that QR code to watch a video that I made that'll show you how to figure out which graph to use with which data. If it's a bar chart, it's going to be words or discrete numerical data. If it's a scatter plot, it's going to be numerical, and usually it's continuous data. Now let's look at an example. And the example that I'm going to use is a continuation from the other two videos on my helicopter experiment. So for my qualitative results, I'll have first of all my title. And the title is Observation of Length of Wingspan in Centimeters versus Time Taken to Fall in Seconds. Remember that when I highlight something in yellow, that's an independent variable, and highlighted in turquoise is a dependent variable. Now I have my table, and you'll notice I have two columns. The first column is always my independent variable. So the heading will be length of wing in centimeters. And I'm going to use the following: 5 centimeters, 4 centimeters, and 3 centimeters. Notice that I just have numbers underneath the heading. I do not have any letters or units. We do not include units. The units are included in the heading only. So remember, these are just going to be numbers. And then we're going to include our observations. So when it's observations for this, it's going to be what I saw happen. So I saw that the helicopter began to twirl from the start, but it did not fall straight to the ground. For 4 centimeters, the helicopter did not fall to the ground straight. It went on a diagonal. And for 3, the helicopter did not begin to twirl until it was closer to the floor, and then it twirled quicker. Again, these are things that I see happen. Now we're going to look at the quantitative or numeric results. Again, I have my title, and it looks really similar to the last one. The last one was observations of. This is raw data of, but notice it's the independent versus the dependent. My table looks a little different, but again, the first column is always going to be my independent variable, so length of the wing in centimeters, and again, 5, 4, and 3 without any units after them. The second column, which I consider all of this is the second column, is going to be my dependent variable, so the time taken to fall in seconds. And remember that we always do 3 trials. Then I write my results. Notice that the results are all to the nearest hundredth. We want to make sure that we are consistent. If I went all to the nearest tenth, that would be fine too. But since I went to the hundredth with the first one, they all need to be to the nearest hundredth of a second. Now we're going to process our data. So again, the only difference in my title is instead of raw data, it says process data. Again, independent versus dependent variable. I have my table. As always, the first column is my independent variable. And again, 5, 4, and 3 is the length with no units after it. And the second column is my dependent variable, the time taken to fall in seconds. And now I'm going to calculate the mean average. So here it is. I added my 3 trials, trial 1, trial 2, and trial 3. I have my total or sum. I divide it by 3, and I notice it's a repeating decimal. So I'm going to round it. And I rounded 3 and 0.366 repeating to 3 and 37 hundredths. Now I rounded it to the nearest hundredth because my raw data was to the nearest hundredth. Your mean cannot be more precise or accurate than your raw data. So if your raw data is to the nearest hundredth, this must also be to the nearest hundredth. For 4 centimeters, I didn't have to do any rounding. It automatically came out to 2 and 57 hundredths. But for 3 centimeters, again, I needed to round to 2 and 43 hundredths. Now we're going to find the mean of the mean. So first we're going to look at the independent variable, the length of the wing. And the length of the wing, I have 5 and 4 and 3. And the sum is 12, divided by 3 is 4. So the mean of the length of the wing is 4 centimeters. We'll do the same with our dependent variable. Again, I'm going to add these 3 amounts and then divide by 3, and I get 2 and 79 hundredths. Now we're going to graph our results. If you need to learn how to make a scatter plot, you don't already know that, you can again check out this video that I did and it explains it for you. So here is my graph. Just a reminder that your independent variable always goes on your x-axis, which is your horizontal line. Your dependent variable always goes on the y-axis or the vertical. And then we have our title. Again, the title looks very similar to what we've been writing before, but notice that I did reverse the order of the independent and dependent. So we say relationship between the dependent variable versus the independent variable. And now I'm going to plot my points. I have 4 points because these are my means of my 3 centimeters, 4 centimeters, and 5 centimeters. And the red one was my mean of my mean. Now, I notice that I have a positive correlation here, the way that they're lining up. So I'm going to draw a line of best fit. And for my line of best fit, it must go through the mean of the mean. So there it is, and it's close to the other points as well. So the results section should be clear, organized, and based only on data. Again, there's no explanations or conclusions yet. That's coming up in our lab report. Use? Well, we use the tables for the raw and processed data. The graphs, whether it's a bar chart or a scatter plot, is good for visualizing the patterns. The means and the measurements are good for summarizing the results. Remember to label everything clearly, your units, your titles, your axes, and your data points. Well-organized results make your findings easier to understand and prepare the reader for your next section, which is the conclusion and the evaluation. So if you enjoyed this video, please click the like button, leave a comment, and if you haven't subscribed yet, please do that. That way you can find out more ways to write your lab report with the conclusion and evaluation, and you'll also have access to all of my videos that I did on mathematics. As always, thank you for watching.